Aloha, my name is Chong Ho Alex Yu. I am a professor of data science and artificial intelligence in Hawaii. In this presentation, I would like to share my idea about democratizing computation with you. When the prominent psychologist Steven Pinker began his graduate studies in the 1970s, he encountered a culture that now sounds almost quaint. He was told that the laboratory computer had to be programmed in assembly language because pre-packaged software was for weenies. At the time, low-level programming was viewed as a badge of intellectual seriousness. One demonstrated scientific rigor not only through experiment design or statistical reasoning but by operating close to the bare metal of the machine. History, however, has a funny way of cycling back. Something similar happened decades later in the early 21st century with the meteoric rise of data science. What began as a multidisciplinary field quickly became almost synonymous with Python programming. Python's popularity grew steadily throughout the 2000s, but around 2010 to 2015 it exploded, propelled by big data, machine learning, and corporate adoption, especially by Google. By the late 2010s and early 2020s, Python topped lists like the TOB index and dominated GitHub repositories, becoming the de facto language for data science education worldwide. So deeply did Python intertwine with data science identity that even when a SAS researcher once presented fascinating results generated with JMP Pro, a polished, dynamic statistical software, the audience questioned the legitimacy of the findings simply because the researcher had not included Python code. The implication was strange but revealing. The method mattered less than the syntax used to produce it. One reason for the dominance of Python and R is their open-source nature. They are free, flexible, extensible, and part of a vibrant ecosystem. Yet many users overlook a crucial point. While software licenses may cost money, so does time. Most open-source tools lack a mature graphical user interface, which means practitioners must spend considerable effort learning syntax, debugging cryptic errors, and mastering programming logic before they can even begin substantive analysis. I once built an entire psychometric item bank using commercial software in just a few days. The project manager, determined to avoid licensing fees, insisted on recreating the system using open-source tools. The result was predictable. 2 full-time programmers plus a research assistant spent months building a system that still lacked the refinement and reliability of the commercial version. Ironically, the salary costs of the team far exceeded the licensing fees that had inspired the switch. This is the hidden cost of so-called free software, a reminder that technical craftsmanship is only one part of solving real-world problems. The overemphasis on coding in data science conflates the means with the end. If the goal is to solve the problem, then the most direct, cost-effective, and intuitive route should be considered the best route. This recognition has fueled a corporate shift back toward low-code and no-code tools, particularly those powered by generative AI. A 2025 research report from Anthropic revealed that many developers now view coding not as an artisanal craft but simply as a means to accomplish a task. Engineers at Anthropic use Claude for roughly 60% of their work, and many report productivity gains around 50%. Routine but tedious tasks, fixing minor bugs, cleaning up code, writing documentation, became dramatically easier with AI assistance, reducing project friction and freeing engineers to focus on higher-level reasoning. Broader industry statistics echo this shift. A 2025 study shows that low-code platforms have helped organizations reduce app development time by up to 90%, allowing non-technical staff to create functional applications and greatly reducing IT bottlenecks. Meanwhile, a 2023 McKinsey study found that developers using generative AI can complete coding tasks as much as twice as fast, reinforcing the argument that labor once considered core can now be augmented. or even replaced, by automated systems. Looking at the history of computing, this movement toward simplification is not new. It is the underlying trajectory of the entire field, a steady democratization through making things easier. First came machine language, composed of raw binary sequences of zeros and ones. This language interacts directly with the CPU, offering absolute control but at the cost of extreme difficulty. Writing a simple arithmetic operation could require a long string of obscure codes. Assembly language was invented to ease this burden by replacing binary instructions with mnemonics like MOV, add, and JMP, but it was still intimately tied to hardware architecture. Only with the development of high-level languages, such as Fortran, COBOL, C, and Java, programming became accessible to a wider technical audience. High-level languages abstract away hardware details by using syntax that closely resembles human language and mathematical notation, such as print, for, x equals y plus 5. At the end, they are translated into machine code by a compiler or interpreter. This significantly increases productivity, portability, and readability. However, the learning curve remained formidable, especially for non-specialists. Whether it's an extra space or a missing semicolon, the program simply won't run. To make matters worse, the resulting error messages read like Martian poetry. Usually most people have no idea of what it means. Nevertheless, this complexity offered me job security. During my time as a graduate student, I was hired as a research assistant to program on an IBM mainframe. If the professor had been able to do it herself, I never would have received a stipend or a tuition waiver. Then came one of the most consequential developments in modern computing, the graphical user interface, GUI. Pioneered at Xerox PARC in the 1970s and popularized by Apple's Macintosh and the Commodore Amiga in the 1980s, the GUI replaced typed commands with visual metaphors, icons, windows, menus, that ordinary users could manipulate directly. But like many technological shifts, GUI adoption faced resistance. Many engineers and business users dismissed the Macintosh as a toy unsuitable for serious work. The Amiga, despite its impressive technical capabilities such as preemptive multitasking, was pigeonholed as a gaming machine. True professionals, the thinking went, used disk operating system on IBM PCs because typing commands felt more authentic, more rigorous. And yet, GUI eventually won decisively. Not because it was fashionable, but because it made computing usable for millions of people who would never have mastered command-line syntax. What critics saw as dumbing down was actually the democratization of capability. In this historical light, the coding boom of the last decade seems less like the natural progression of computing and more like a brief disruption of the long-term trend. The rise of no-code and low-code tools, supercharged by generative AI, has swung the pendulum back toward ease, speed, and inclusivity. The goal is no longer to demonstrate mastery of syntax, it is to achieve outcomes. Coding is one way to do that, but not the only way, and increasingly not the fastest. I say this as someone who codes. I am not opposed to programming at all. It is intellectually satisfying and sometimes necessary. But coding should be treated as a means, not the ultimate goal. Learning data science primarily through programming is like learning physics using Latin as the language of instruction. That extra layer of complexity, however noble, can obscure the subject matter itself. Besides, the labor market has already changed. Entry-level and even mid-level programming tasks, routine scripting, data munging, boilerplate code generation, are increasingly automated by AI. It is therefore reasonable to ask whether students should invest their time mastering syntax or whether they would be better served by strengthening skills in critical thinking, abstraction, problem definition, interpretation, and ethical reasoning. These are the skills that remain robust when tools evolve. There are domains where deep mastery of syntax remains irreplaceable, or contexts in which no-code or low-code tools cannot yet deliver. But the broader trend seems clear. Computing is becoming more human-centered, and generative AI is simply the latest step in a decades-long journey toward making powerful capabilities accessible to everyone. If that helps us spend more time solving problems and less time wrestling with semicolons, then perhaps the evolution is not just inevitable but overdue. I welcome counter-examples and alternative perspectives. If you found this video informative and thought-provoking, please like, share, and subscribe. Thank you for watching. Mahalo.